Hello! In this video, we will learn about the sliding window algorithm. This is basically an algorithm that, if provided with a large amount of data, manages it in chunks in the shape of a window rather than managing the entire data set all at once. For example, imagine you are standing here like this person looking for a specific book. You know which book it is among all the books in the library. You start by taking 3 books forming a window. You move them aside, look at one of them, then move one aside and discard it, and add a new one at the front. By doing this little by little, you will reach the book you are trying to find. Let me give you an example from our Ngram tool. Let's say we change the text in the Ngram tool, and it creates Ngrams. How does it do this? In a bigram, it takes 2 words, then moves 2 steps forward. It is given the command to move 2 steps forward. It does this by dropping one word and picking up the next word. Then that next word will appear in the next sentence. The last word of the previous chunk becomes the first word of the next chunk. By doing this, you will see that the whole set is created. If we look at others like the trigram, the same process applies, and the same is true for the 4-gram, 5-gram, and 6-gram. The first word is dropped and the last word is added. This is how we proceed. Its key points include having a fixed size such as bigram, unigram, 6-gram, 5-gram, or 4-gram. This means a fixed window is provided to it, instructing it to proceed in this sequence. Next is sequential movement. It moves gradually, advancing step by step in a sequence. Next is efficiency. It uses less computer power and works quickly. If there is a large task or a large amount of data, it can easily manage it by dividing it into chunks. Now, how does the sliding window algorithm work within NLP? There are quite a few things where it is used. First up is Ngram generation or extraction. It is used if Ngrams need to be extracted or generated from a sentence, just as I showed you with our Ngram tool. Following the same algorithm and same mechanics, Ngrams are generated. They move into the window and are extracted. Next is feature extraction. The TF-IDF score is extracted using this, and the word frequency is extracted, showing how many times a particular word has been used. Next are contextual embeddings. Context-sensitive embeddings are generated for words and sentences using this. Next is sentiment analysis. If you analyze product reviews using sentiment analysis, you can extract certain words that give you an idea of whether the customers are happy or angry, what their reaction is, and what their feedback is about the product. Next is named entity recognition. By using this with NER, entities can be extracted from specific text windows. Let's look at an example. The quick brown folks jumps over the lazy dog. The window size is set to 3, so it processes it in windows. The quick brown, then quick brown folks, the first word is dropped, then brown folks jumps. In this way, it continues to move forward in chunks, performing its tasks. Now let's look at its benefits. First is efficiency. It uses less power and can work on large data by breaking it down into chunks. Next is decreased memory usage. It uses less memory. Next is real-time processing. When we provide data, it performs the analysis in real time. Next is simplicity. It is easy to implement. Next is versatility. Many tasks in NLP are performed using this algorithm. Next is contextual analysis. It makes it possible to observe the relationship in a context among words within each window. Now, what are its real-world applications? Text submissions, breaking down large text into smaller text and analyzing them. Next is the extraction of specific features. Next is recognizing specific patterns, Ngrams, expressions, and so on.